6, solve systems of linear inequalities. We are going to graph this slope-intercept form. Here we can see that my slope is -1, and my y-intercept is -2. -2, and rise 1, run -1 for my slope. Y is greater than, so it's going to be a dotted line. Now I need to shade. I'm going to choose the point 0, 0. If I get a true solution, then I will be shading on this side of the line. If I get a false solution, then I'll be shading on the other side of the line. When I substitute in that x is 0 and y is 0, I get a statement that says 0 is greater than -2. That is true. That means I chose 0, 0, and I got a true statement. I'm going to be shading on this side of the line. Now we have y is less than or equal to 3x plus 6. My slope is 3. My y-intercept is 6. So my y-intercept is 6, and then I'm going to rise 3 and run 1. 1, 2, 3, and run 1. It says that it is less than or equal to, so this time it will be a solid line. And I'm going to check for shading. I'm going to pick 0, 0 again. If I get a true statement, I'll be shading on the bottom of the line. If I get a false statement, I'll be shading on the other side of the line. We have 0 is less than or equal to 3 times 0 plus 6. We get a statement that says that 0 is less than or equal to 6. That is true. That means I'm going to be shading on this side where 0, 0 was. All right, where are my solutions? I'm looking for the checker pattern because that is where both of the lines have been shaded. Here, only one of the lines have been shaded. Over here, no lines have been shading. Here, only one of the lines has been shading. So my solution is going to be where they're both being shaded, which would be that checker pattern that I created here. So my solution, I can pick any point that is in that region, and it will work for both equations. Inequalities have an infinite number of solutions. So if I chose the point, let's say I picked the point 4, 0. I want to check that point. I'm going to come up top here and check. We're going to check the point 4, 0. In the first equation, we have y is greater than -x, -2. So when I substitute in that point, I get 0 is greater than x is 4. I get a statement that says 0 is greater than -6. That's a true statement. It works for the first equation. And now I'm going to check the second equation. Y is less than or equal to 3x plus 6. When I substitute in my y and I substitute in my x, we get a statement that says 0 is less than or equal to 18. That is true. That means that I have shaded the correct area and all my solutions are here in this region. For the next part, we have y is greater than -1. Y is greater than or equal to -1. That is a horizontal line. Here is where y equals -1. It says greater than or equal to. That is a solid line. And it says that y is greater than -1. Well, if I pick a point down here, is that going to be greater than -1? No, my solutions are up here on top. Next, we have x is greater than -2. This is a vertical line. A vertical line at x equals -2. And it says x is greater than -2. Not on this side. This is where it's less than -2. This would be where it's greater than -2. So far we can see that this is where they're overlapping. And we're not going to find a solution that are in these other regions then. It's going to have to be somewhere near this region. We still have one more equation. And this is an equation that's in standard form. So I'm going to graph it using intercepts. When y is 0 and when x is 0. I'm going to use those x and y intercepts. When y is 0, we get a statement that says x equals 4. And when x is 0, we get a statement that says 2y is less than or equal to 4. When I solve for y and I divide by 2, we get that y equals 2. I'm going to plot these points at 4, 0, 0, 2. And it does say less than or equal to. I'm going to make a solid line. And now I need to figure out where is it going to be shaded, on top or on bottom. Here, I'm going to pick a point and check for shading. Let's pick a point at 0, 0. That's always a nice, easy point to pick. So we're going to check 0, 0 for shading. So we have x plus 2y is less than or equal to 4. X is 0. Y is 0. And we get that 0 is less than or equal to 4. That's true. I chose 0, 0, so that means that I'll be shading down here. Here, below the line. All right. I'm looking for a region where all three of them are there. I've got blue and green, blue, blue and red, red, red and green. I would say that from this function over here in the triangle shape here, that is where you're getting all of your functions shaded. Now we're going to go in the opposite direction and we're going to write an equation from a graph. Let's start with this horizontal line that is at 3. And so we know horizontal lines would be y equals a number. And it is a solid line, so it's going to have the equal sign. And where is it shaded? Is it shaded greater than y or less than y? It is shaded greater than y. So y is greater than or equal to 3 would be the first equation. For the second equation with a slanted slope, we're going to think about y equals mx plus b. What is my slope? What is my y-intercept? Because then I can write an equation of a line. My y-intercept is at 1. It's intercepting the axis at 1. And my slope is rise 2 and run 1. My slope is going to be 2 over 1, which is just 2. So I have my m, I have my b, my slope is 2, and my y-intercept is 1. I just need to see where it's shaded. Y is greater than the line, or Y is less than the line. I would say Y is greater than. It's been shaded on top. Y is greater than or equal to, nope, just greater than. Y is greater than, because of the dotted line, 2x plus 1.